Hello everyone, this is Abdullah Kassir from ADAX, and in this video we will show how to use TFAT NLFM 2025 to analyze fatigue crack propagation through a rectangular block based on linear elastic fracture mechanics, LEFM. TFAT NLFM 2025 is a software released by ADAX that provides fracture mechanics fatigue crack propagation based on both J-integral theory for elastoplastic materials and stress intensity theory for linear elastic materials. So TFAT NLFM provides submodeling capabilities with crack insertion and refined remeshing. So you can submodel your global model, you can insert a crack, and you can also remesh this cracked submodel with the mesh being refined around the crack front. TFAT NLFM also provides delta J computation and stress intensity factor computation along the crack. It provides automated crack advancement. Finally, it provides crack propagation using different fatigue crack propagation laws. So in this video, we will go through one of the tutorials that comes with the software, which is based on LEFM. The tutorial involves a rectangular block under cyclic tensile loading with a corner crack. Okay, to start the tutorial, we will go ahead and launch the application. We first press Open IMP, navigate to Tutorial LEFM folder, select corner crack sample job.imp, open the file. You can see our rectangular block model here. Okay, so we want to insert a crack halfway through the block at the corner such that the crack is parallel to the XZ plane and normal to the Y vector. We give a name to the hotspot, HS1. We select the node number 78. So this node happens to be approximately halfway across the block. Okay, and we select the critical plane normal to be the Y-axis. Okay, we press apply and then next. So for this model we will not be doing some modeling. However, we need to preserve the top and bottom insets. One of them will have the boundary condition applied and the other will have the load applied to it. Okay, so then we press next. Okay, so we want an initial crack size. We want it to be 4. Okay, so 4 is the diameter of the crack, so the radius of the crack will be equal to 2. We keep the element size as 3, the crack resolution as 0.05. So the crack resolution is the element size around the crack front. Okay, the desired element size around the crack front. And we set the fine region to 0.15. So the fine region is the region around the crack front that will have an element size of 0.05. Okay, so now we can press preview to see how our cracked submodel mesh will look like. Okay, we just wait for it to finish. Okay, and as you can see, here's our cracked model with the crack at our hotspot. Okay, we press hide and then next to move on to the next page. So in this page we have to enter our analysis parameters. So first we need to select our material file, enter our abacus command. So this is the command that's going to be used to launch abacus. Okay, we select our initial crack increment number to be 0. So we don't have any previous simulation. Okay, so we have to start with 0. We enter 10 crack increments. We have 8 cores on this computer, so we have to select the number of CPUs equal to 8. In this IMP, we only have 2 steps, okay? And we will use these 2 steps to compute our stress intensity factor, okay? So we're done with this page. Okay, so now we press next. So like we said in the beginning, our simulation will be based on linear elastic fracture mechanics. So we press the LEFM tab, and we have to enter all these NASGRO parameters, okay? So these parameters are explained in details in the manual, okay? And the values for these parameters for this tutorial are also listed in the manual. So I'll just copy them from the manual for now. You can refer to the manual for further details. Okay, and we'll enter a cycle skipping factor of 4,000. So the cycle skipping factor tells us how many cycles we will simulate per crack advancement. Okay. So then we press apply, then next. Okay, so at this stage we can prepare our IMP file. We press prepare IMP. Okay, so what we need to do is we need to change the offset name to part 1. Okay, and that's all we need to do. Okay, so now we're ready to press save, close the IMP file, and start the analysis. Okay, we have to wait for the analysis to finish. It could take some time. Okay, and we'll come back when the analysis is done. Okay, so we're back. Once the analysis is done, we press the reload button, and we'll wait for the software to read the data of all the crack increments. So in this case we have 10 crack increments. Okay, so when it's finished reading the data, we can go here and hide the global model. Okay, and we can see the Mises plot of the cracked submodel. So this is for the initial crack. Okay, we can change the visualization to surface with edges. Okay, we zoom in, you can see the Mises plot around the crack. Okay, you can hide this plotting area for a second. Okay, so we get a bigger view. Alright, so, and we can step through the increments one by one. Okay, and we see how the crack propagates through the block, starting from the corner. Okay, and we can also go back to the beginning, or we can go to the end. Okay, you can see it's almost cut through half the block. Okay, and we can also animate the crack propagation with the Mises plots. Alright. Okay, so, and we can also plot the crack front lines. Okay, we can rotate and we can see the crack front lines. So each one of these represents one of our crack increments. We can also plot the depth versus the number of cycles. Okay, so the red and blue lines represent the crack tips distance. Okay, and the green line represents the crack depth at the middle of the crack. Okay, and we can also plot the Kmax value over the number of cycles. So this value is at the middle of the crack. Okay. Can we close it? Okay, let's bring back our plotting area. Alright, so in this plotting area here, okay, at the bottom right, we have the results for each increment. Okay, and for each increment we have the values of K1, so K mod 1, K mod 2, K mod 3, plotted over time. Alright, and for all sections. So sections are distinguished by different colors. Okay, and here we have the values of K1, K2, and K3. Okay, so a section is a section of the crack front. Okay, so from the first crack tip to the last one. Okay, and Kmax value, the Kmax is plotted across the crack front. Okay, so this is the max over time for K1, and it's plotted for all domains coded by color. Okay, so from domain 1 to domain 5. Okay, so domains are the integration domains around the crack front. So like how many layers of elements. Alright, and we can step through the increments and we can see how the Kmax value progresses. As you can see, it's typically increasing. Okay, so the crack has a higher tendency of increasing in size. Okay, so the crack rate is increasing with time. Alright, so that's all for this video. If you have further questions, please visit our website at adax-eng.com. Thank you.